One of the strongest earthquakes in Texas history was felt in parts of North Texas.
21 here on the air. We're experiencing very strong shaking.
Wow. At the break of dawn, a massive earthquake shook the very core of Texas, leaving behind a path of destruction and chaos. It's the most powerful quake ever recorded in the Lone Star State, triggering widespread evacuations by scientists. The tremors were so intense that they rippled across the region, sparking an extraordinary emergency response. What could be the cause of this surprising environmental change, and could it be linked to human activities? Join us as we unravel the mystery behind the powerful earthquake that struck Texas. Earthquake and Geology of Texas. In the early hours of July 26, 2024, around 3:45 a.m., Texas experienced an event that few could have ever imagined. A huge and sudden earthquake hit the state. This was no small shake, it was a powerful quake, measuring 5.1 on the Richter scale, making it one of the strongest earthquakes ever recorded in Texas history. The center of this unexpected disaster was near the town of Pozos in western Texas, but its effects were felt far beyond. The ground shook violently, causing buildings and roads to crack and fall apart, with the worst damage occurring in the western parts of the state. Even areas as far north as Dallas felt the earth tremble beneath them. The quake's force was enough to split walls and bring down older buildings, leaving the landscape damaged and residents in shock. Miraculously, no lives were lost, but many people suffered serious injuries from falling debris. As the dust settled, scientists and researchers quickly sprang into action. Experts from the permanent research centers were evacuated, and teams of seismologists were sent to assess the situation. They wasted no time setting up mobile seismic stations to monitor aftershocks and gather important data. Unlike fixed stations, these mobile units were designed to be quickly set up and moved as needed, a crucial feature given the unpredictable nature of the earthquake. This unprecedented event highlighted the importance of quick and decisive action in the face of natural disasters, as researchers worked tirelessly to understand the quake and prevent further damage. When the next earthquake hit, the community took quick action to deal with the situation. Local emergency services were immediately deployed to help with the crisis. They assessed the damage to buildings and provided urgent medical care. Temporary shelters were set up for people who had lost their homes due to the quake's severity. Some individuals were advised to leave their homes because their houses were so badly damaged that they could collapse at any moment. Through social media and major news outlets, people stayed updated on the ongoing efforts and safety measures, ensuring everyone knew what to do. Major roads and bridges are currently being inspected for safety, and some are closed for repairs and quality checks. This situation also raised concerns about the safety of oil and gas extraction activities, which have been linked to increased seismic activity in the region. The costs of repairs and the economic impact of the earthquake are expected to affect local businesses. Authorities are considering changes in safety regulations and protocols to prevent future issues. Meanwhile, scientists at mobile research centers have been studying the earthquake and have noticed several aftershocks in the days following the main quake. Most of these were minor and caused little damage. These scientists are also investigating whether oil and gas extraction, commonly known as fracking, might have played a role in this disaster. Their initial findings suggest that injecting wastewater into deep wells might have contributed, but this theory still needs more evidence. This event has highlighted the need for better earthquake preparedness and response plans in Texas, including improved building codes and more effective awareness campaigns. As scientists work on better predictions for future earthquakes, it's crucial to be well prepared for any upcoming seismic events. This situation is tough because it's something we haven't seen before. Even though earthquakes are hard to predict, it doesn't mean we couldn't have been ready for one. If we look into Texas's history of earthquakes and the geological data, it becomes clear that such an event was quite likely. The evidence suggests we might expect earthquakes more frequently than we thought. It might be surprising to learn that Texas has a rich geological history that spans over 1 billion years. This long history includes many different events that have shaped the land over thousands of millennia. Recent earthquakes are just one example of how these ancient processes continue to influence the region. The earliest chapter in this geological story is the Precambrian era, which began over 1 billion years ago. Some of the oldest rocks found in the Llano Uplift region come from this era. These rocks are incredibly ancient, more than 1 billion years old. Scientists think they were originally formed deep inside the Earth, but were later brought to the surface through massive erosion. These ancient rocks contain fossils of marine creatures like brachiopods, trilobites, and other early life forms. Studying these fossils gives us a window into the early history of North America. When these rocks were exposed, it marked the end of that ancient geological period, providing valuable insights into Earth's distant past. The period that came next is called the Paleozoic era, which started over 500 million years ago. During most of this time, Texas was covered by shallow seas. These seas caused lots of tiny sea creatures and other marine materials to settle on the ocean floor. Over time, these sediments piled up and turned into special rocks rich in minerals like limestone and shale. Some of these sediments came from the remains of ancient sea creatures, and their preserved parts, known as fossils, have been found in Texas. These fossils have turned into valuable minerals used in the oil and gas industry today. Towards the end of the Paleozoic era, huge pieces of the Earth's crust collided, forming the mountains that we now see along the eastern edge of Texas. This mountain range is known as the Ouachita Mountains, or the Ouachitas for short. The formation of these mountains marked the end of the Paleozoic era and the start of the Mesozoic era. The Mesozoic era started around 200 million years ago. At the beginning of this time, the giant landmass called Pangaea began to split apart. This breakup created what we now recognize as the Gulf of Mexico. As the tectonic plates moved apart, deep rifts formed, and these rifts were filled with layers of red rock made mainly of sandstone and shale. Unlike the Paleozoic era, when Texas was often covered by shallow seas, during the Mesozoic era, the flooding was less frequent and only happened at certain times, especially during the Cretaceous period. During this era, Texas was home to some of the most fierce dinosaurs, including the famous Tyrannosaurus rex. Fossils of these dinosaurs can be found at special places like Dinosaur Valley and Glen Rose, where you can see well-preserved dinosaur tracks and remains. Next came the Cenozoic era, which began about 70 million years ago. In Texas, this era started with major geological changes. The Rocky Mountains to the west of Texas rose significantly, which greatly impacted the state's landscape. Western Texas experienced intense tectonic activity that led to the formation of the mountains in the Trans-Pecos region. In this area, you can find the Davis and Guadalupe Mountains. The volcanic activity here long ago reshaped the landscape, creating major features like the Big Bend region. As the Gulf of Mexico slowly opened up, it deposited large amounts of sediment along the Texas coast. This process formed what we now call the Gulf Coast Plain. About 3 million years ago, a new era began, known as the Quaternary period. During this time, the landscape started to take on its current form, giving rise to the deserts, plains, and coastal regions we are familiar with today. Rivers continue to wash away and deposit material, continually shaping the land. Many of the important geological features we see now can be traced back to various periods in Earth's history. One key feature is the Balcones Fault Zone, which cuts through Texas and divides the Edwards Plateau from the Gulf Coastal Plain. This fault was created by tectonic forces that lifted the plateau, resulting in its distinctive limestone layers and karst formations. Over millions of years, Texas has undergone significant changes. The ground has shifted and cracked, leading to the landscape we see now. This ongoing movement means that earthquakes like those we've experienced recently are not unusual. They reflect the natural tectonic activity that has shaped the region for a very long time. We'll explore notable earthquakes in Texas, including some that were quite severe, and discuss how they are linked to these natural tectonic processes. One of the most significant earthquakes in Texas history is the 1931 Valentine earthquake. This quake, which hit on August 16, 1931, is the largest ever recorded in Texas, registering a magnitude of 5.8. The tremor was felt across a vast area and caused notable damage in the small town of Valentine, where several homes collapsed. Thankfully, no one was hurt. The earthquake happened due to stresses in the Earth's crust, known as tectonic forces. The next major earthquake in Texas occurred on April 13, 1995. This event, commonly referred to as the Alpine earthquake, struck near the town of Alpine. The quake, with a magnitude of 5.7, was also felt in nearby towns like Fort Davis and Marathon. While it did cause some damage to buildings, there were no serious injuries. Like the Valentine earthquake, this one was caused by tectonic movements, specifically related to the Trans-Pecos faults. Fast forward to 2011, and Texas experienced another notable quake, known as the Fashing earthquake. On this occasion, a 4.8 magnitude quake hit near a small community in South Texas. This earthquake was unusual for the region, prompting scientists to investigate its origins. After months of study, they concluded that the quake was most likely triggered by the uncontrolled extraction of oil and gas, rather than natural tectonic movements. About 50 miles away in San Antonio, a tremor was felt, causing only minor damage to older buildings. 7 years later, a new earthquake, known as the 2018 Amarillo earthquake, hit with a magnitude of 4.0. While not as strong as some earlier earthquakes, it was noteworthy because it struck an area not usually associated with earthquakes. This quake caused minor damage, but no injuries, and was much less severe than the earlier Mentone earthquake, which had a magnitude of 5.0 and occurred on March 26, 2018 in far western Texas. The Mentone quake's effects were felt as far away as El Paso and Midland, but experts were not surprised because the region had been experiencing increased seismic activity due to wastewater injection by mining industries. The next significant quake was even stronger, with a magnitude of 5.4, making it the third strongest earthquake in Texas history. This was the 2022 Midland earthquake, which struck on December 16th and was widely felt across the Permian Basin, a region known for extensive oil production. Today, the Midland area continues to experience significant seismic activity, which is also linked to oil and gas production and the disposal of wastewater into deep wells. Many areas with rising earthquake activity are places with high oil and gas production. This is because the process of extracting oil and gas, known as fracking, can increase seismic activity. Fracking involves injecting fluid into the ground to break up rock and release oil or gas, which can sometimes lead to increased earthquakes. Now, let's explore how this process might contribute to stronger quakes. Fracking process and implications. In simple terms, fracking involves injecting a mix of water, sand, and chemicals into a well with high pressure to create small cracks in deep rocks. When these rocks crack, oil and gas can flow more easily into the well. This process happens thousands of feet below the Earth's surface. However, the increase in earthquakes is more related to how the wastewater from fracking is disposed of, rather than the fracking itself. During fracking, a special mixture called wastewater is used to create these cracks. This wastewater is often pumped into much deeper underground wells known as disposal wells. This rapid injection of wastewater raises the pressure on fault lines in the Earth's crust, making earthquakes more likely. These earthquakes can range from small tremors to significant disasters. The more wastewater that is disposed of, the higher the chance of stronger earthquakes. This is because the injected fluids reduce friction along existing faults, making it harder for them to hold back the growing pressure that triggers earthquakes. Many experts and concerned citizens, including retired police officer Don DeVille, have voiced their worries about this issue. According to a report from the Texas state agency that monitors the oil and gas industry, inspectors found that certain wells filled with salt water were located in a 2.5-mile area where over 100 earthquakes had been reported within a week. The Texas Railroad Commission reported a series of earthquakes in the Camp Springs area along the Scurry County line. The report noted that several operators were trying to address the rising number of earthquakes by changing their method of disposing of salt water. They planned to switch from using deep saltwater disposal wells to shallower ones. In 2023, Don DeVille, a retired police officer, decided to use his old detective skills to investigate. DeVille had worked with the railroad for 35 years after his police career. He started by mapping out the locations of oil and saltwater disposal wells near his property. He compared earthquake data from May and June to that from July, and what he found was alarming. the number of earthquakes in July was twice as high as the total for the 2 previous months combined. Additionally, he discovered that the number of earthquakes in 2021 had significantly surpassed the number from the previous year. DeVille concluded that the increased seismic activity was due to human actions driven by greed. He shared his concerns in an interview with CBS News. According to the Railroad Commission, the disposal wells were used to inject mineralized water, a byproduct of oil and gas production, into the ground. The situation was worsened by the overuse of these wells, with over 100 earthquakes occurring in just 2 weeks. DeVille believed that too much was being dumped into these wells, and that this was causing frequent earthquakes. When asked how often earthquakes occurred, he said they happened at least 4 times a day. Even after years of dealing with earthquakes, DeVille and his wife still find each tremor just as unsettling. One of the most significant quakes they faced was on July 26, 2024, when a 5.0 magnitude earthquake hit their area. DeVille said this quake was so powerful that it flipped the chair he was sitting in. For a moment, he feared that his house might collapse on him. With only 10 seconds to protect himself, he knew what to do during an earthquake, but his age made it harder to act quickly. Despite his extensive experience with earthquakes, DeVille told CBS News that as a husband and father, he is deeply worried about his family's safety. He noted that the quakes have been growing in strength, from small tremors of just 1 point to more serious ones over 5.0. He admitted he's anxious about what might happen if a 6-point quake hits Texas, fearing it could happen anytime soon since the quakes have been getting stronger each week. DeVille showed how his home has been affected. There are cracks along the ceiling and nails poking through the roof. Outside, the ground has shifted, leaving noticeable cracks around the sides of his house. His friend Joe Hodges' house has similar damage, with cracks appearing in multiple rooms and more gaps forming outside with each quake. Neither DeVille nor Joe plans to repair the damage, believing that investing in repairs would be a waste of time and money given the ongoing risks. The retired police officer mentioned that he and his wife are thinking about selling their home so they can move in with their daughters. He's become quite upset with the frequent earthquakes in their area. He even questioned why anyone would want to buy the property under these conditions. Like many experts, he believes that the recent earthquakes might be related to oil and gas drilling. What's particularly interesting is that one of the most well-known examples of earthquakes caused by drilling is in Oklahoma. Since 2009, the state has seen a huge increase in earthquakes, and this rise started the same year Oklahoma's oil and gas production went up a lot. Some of these earthquakes were strong enough to damage buildings and other structures. Texas has experienced a similar rise in earthquakes, especially in areas like the Permian Basin and near Dallas-Fort Worth. These earthquakes are also linked to the practice of injecting wastewater into the ground, which has caused many quakes. In response to this problem, people have suggested several alternative solutions, such as using renewable energy sources, improving geothermal systems, and producing biogas. While these alternatives might seem promising at first, they also come with their own set of challenges. One suggested alternative to traditional energy sources is renewable energy. While renewable energy usually has fewer negative effects on the environment, it has some drawbacks. One major issue is that it depends heavily on specific weather conditions, such as sunlight for solar power and wind for wind turbines. These conditions aren't always available, leading to uneven energy production. This unpredictability contrasts with the more reliable energy sources we're used to. Moreover, the most effective ways to store renewable energy, like large batteries, are still quite expensive and not widely available. This makes it hard to save enough energy for times when it isn't being produced, especially during periods of low production. Additionally, large-scale renewable energy projects, such as wind farms and solar fields, require a lot of land. This can disrupt natural habitats and lead to conflicts with landowners. Another option is improved geothermal systems, which could provide a more stable energy source without harming the environment. However, these systems are costly to build and depend on specific geological conditions that aren't found everywhere. Interestingly, while some view geothermal energy as a better alternative to fracking, it can increase the risk of earthquakes because it involves injecting fluids into the ground to access the heat. Another possible solution is to use waterless fracking methods. This involves using liquefied propane gas instead of water. This approach can lessen the environmental impact because, unlike wastewater, propane gas can be reused, creates less waste, and is less likely to trigger earthquakes. However, propane is highly flammable, which makes the process more dangerous. Additionally, using propane is more expensive than traditional wastewater fracking and would require significant changes to current methods. These adjustments would be costly, making this approach impractical in the short term. On the other hand, using microbial gas has its advantages. This method uses microbes to turn organic materials into methane, which can be a clean energy source. However, the process is very slow and not as efficient as conventional methods. Scaling up microbial gas production to meet daily energy needs would be challenging due to its slow pace. Even if we had the time to develop this method, it is still in the experimental stage and not yet a viable option. One alternative to traditional energy sources is biogas, which comes from breaking down organic waste. However, there are some challenges with using biogas. First, the amount of organic waste available can vary, making it an unreliable source of energy. Additionally, biogas plants can produce strong, unpleasant smells if not managed carefully. Another issue is that biogas production can be affected by changes in the market or government policies. It's also important to remember that our economy heavily depends on oil and gas. If we were to stop oil extraction and switch to new energy sources, it could have a negative impact on the economy. Each alternative energy source comes with its own set of problems, so it's not enough to just stop fracking and try new methods. For now, the best approach is to manage our current energy situation as effectively as possible. Advances in research are helping with this. Scientists use new technologies to monitor seismic activity and plan to reduce damage and protect lives. Next, let's examine each of them together. Research methods and indicators. Scientists use many different research methods to study recent earthquakes. These methods help them understand what caused the earthquake, its features, and its effects. To do this, they rely on special tools called seismographs. These instruments detect and record seismic waves, which are vibrations that travel through the earth. By measuring how the ground moves in different locations, seismographs provide detailed information about the earthquake's size, depth, and location. One important system used for monitoring earthquakes is the Texas Monitoring Network, also known as the TexIT system. This system was set up to keep track of earthquakes, especially in areas where oil and gas extraction is common. The TexIT system helps scientists find the exact place where an earthquake starts by looking at how long it takes for seismic waves to reach different seismographs. Using this information, scientists can determine the earthquake's starting point by triangulating, which involves calculating where multiple measurements meet. Scientists can measure the strength of an earthquake by looking at the size of the seismic waves it produces. These waves are recorded by instruments called seismographs, which use a special scale known as the Richter scale to determine how powerful the earthquake was. After the earthquake, scientists continue to monitor the area for aftershocks using a network of seismic sensors. This is important because aftershocks provide extra information about the fault line that caused the initial quake, helping to make better predictions for future earthquakes. The pattern and frequency of these aftershocks give scientists clues about changes in the Earth's stress and how faults behave. To better understand these faults, scientists conduct geological and geophysical surveys. These surveys help map out the faults that cause surface ruptures and major seismic events. After a significant earthquake, these surveys are especially important as they help geologists learn more about the faults, which can provide insights into potential future earthquakes and even volcanic eruptions. To understand what's happening beneath the Earth's surface, scientists use various techniques to create images of hidden structures. Two common methods are seismic reflection and refraction surveys. These techniques allow researchers to see fault lines and get a clearer picture of the geological setting related to recent earthquakes. In addition to these methods, scientists use GPS data to track changes in the ground caused by earthquakes. Advanced GPS stations measure how positions shift before and after an earthquake, helping determine how much the Earth's crust moved during the event. Another tool, called Interferometric Synthetic Aperture Radar, INSAR, uses satellite data to measure ground movement and also assesses the amount of crust movement during earthquakes. Scientists have also explored the relationship between seismic events and human activities. They found that some earthquakes might be linked more to human activities, such as oil and gas production, rather than just natural tectonic shifts. By analyzing factors like the location of nearby wells and the amount of wastewater injected into them, researchers can better understand how mining and other activities might be connected to seismic events. To make future earthquake predictions more accurate and reduce damage, scientists use digital polls on social media. The United States Geological Survey-USGS- employs these polls to understand the intensity and spread of earthquakes by gathering quick responses from people. A great example of this is the "Did You Feel It?" survey on social media, where people can easily report their earthquake experiences. By analyzing the results from these polls, experts can draw precise conclusions about the earthquake's effects based on the citizens' reports. The data collected helps geologists refine their digital models, which simulate earthquakes. These updated models can give better predictions of how the ground will shake and the potential damage from future quakes. However, it will take time to see how much these new models improve compared to the previous ones. Through collaboration with universities and government agencies like the USGS, scientists can provide valuable information that helps raise public awareness and improve safety measures. Now it's time for today's subscriber pick. Scientists evacuated Texas after a massive earthquake hit the city. In the heart of Texas, a rumble shook the ground one sunny morning. A massive earthquake, stronger than anyone had ever seen, cracked the earth and rattled buildings. Scientists, watching in shock, quickly realized this wasn't just a small tremor. It was a disaster waiting to happen. With buildings swaying and roads splitting apart, the scientists sprang into action. They knew the quake would get worse, so they urgently warned everyone to leave their homes. The people of Texas, terrified but trusting the scientists, packed their bags and fled to safer areas. Streets once filled with bustling activity were now empty and quiet. As families gathered in evacuation centers, the ground continued to tremble, but they were safe, away from the chaos. The scientists worked tirelessly to understand what caused the quake and to plan for rebuilding. The earthquake had caused great damage, but the quick actions of the scientists and the bravery of the people helped save countless lives. What do you think the future holds for Texas after this quake? Let us know your answer in the comments section. Precautions and safety measures. To prevent the kind of damage we saw from this earthquake from happening again, both the government and everyday people need to take action. Even though more earthquakes are occurring due to oil and gas production, it's clear that this mining process isn't going away anytime soon. Texas relies heavily on these activities, so stopping them isn't feasible. Instead, citizens should focus on reducing potential damage as much as possible. One effective way to do this is by enforcing strict building codes. These codes would ensure that all new buildings are designed to handle even stronger earthquakes. The government can also improve evacuation plans and emergency response systems. By doing so, they can reduce the problems caused by damaged roads when the next major earthquake occurs and ensure that people who are hurt receive the medical care they need. To help children know what to do during an earthquake, schools could include earthquake safety in their lessons. This way, kids will automatically learn how to react when an earthquake happens. For everyone else, there are several steps to prepare for future earthquakes. One important measure is to secure heavy furniture and appliances to the walls of your home. This prevents them from falling during strong shaking and potentially injuring people. Additionally, it's wise for every family to keep a good supply of food and medical items at home. This way, they can take care of themselves for a while before emergency services arrive. Families should also create and practice evacuation plans. While these drills might seem unnecessary, they can be very useful when an actual earthquake occurs. Furthermore, everyone must stay informed about the latest earthquake predictions from experts. By doing so, you can stay up to date with the latest information and take the right steps to keep yourself safe. It's important to understand that most earthquakes in Texas are too small to cause serious damage. In other words, there's no need to panic. People are only advised to take extra precautions because experts have noticed a trend of stronger earthquakes lately. However, it's still unlikely that the next earthquake will be catastrophic. Many people in California, for example, joke that they sleep soundly during magnitude 5 earthquakes, whereas some Texans might worry a lot about them. The Texas Department of Emergency Management reported receiving a total of 85 inquiries about recent earthquakes in just 1 week. They noted that none of these inquiries involved damage severe enough to need federal disaster assistance. The earthquake on July 26th was part of a series of over 100 quakes affecting West Texas. The situation is ongoing, and authorities are working to address the immediate needs of affected communities while investigating the causes of the increased seismic activity. What are your thoughts on the massive earthquake that hit Texas? Share your thoughts with us in the comments section.